Hello guys. So in this video we are going to learn about what are the drawbacks of a singly linked list. We already have seen that for a singly linked list, like we have certain nodes and each node carries the address of the next corresponding node in the pointer field or in the next field, and there is a data associated with that. So we for each node we are storing the data as well as the address of the next node, and for each node we can traverse only in one direction. There is no backward traversal possible, and that we have seen in reversing the linked list, that we can reverse a linked list but we cannot travel backward, right? So let's now learn about what are the limitations of a singly linked list. Okay, so this is the last node that contains the null pointer, and there is a head that is addressing the first node of the linked list, right? So what is there here? What are the demerits? Before going into that, first let's learn about the time complexity for certain operations that we can perform on the linked list. So right now we have two operations that we have seen in videos, that we can perform the insertion of a particular node at either at the beginning or at the end or the specified position, and also we can perform deletion. Okay, so deletion can also happen at the beginning or at the end or at a particular position specified by the user. So all this can happen either at the beginning of the linked list or at the end or at position P. Okay, so let's learn about the time complexity involved when we are inserting a new node at the beginning of the linked list. So when we have to insert a new node here, so the only thing that we need to do is just to update the new node address in the head pointer, and we need to update the links so that the new node corresponds to this original head, right? So this is just done, can be done in the constant time. Similar way, if we have to remove this particular node from this linked list, we just need to break this link and deallocate the memory space and update the head pointer to pointing to the second node so that it becomes the first node of the linked list. So obviously the insertion at the beginning or the deletion at the beginning can be done in constant time. So if we look at the time complexity, for the insertion it takes order of one time, that is constant, and deletion also constant. But let's look, if we want to insert a new node here or at the end of the linked list, then definitely we need to traverse down till that position or till that end. So in worst case scenario, it will take order of n time. Similar way, if we have to delete a node, then also we need to traverse up to that position or up to the end, and we can delete. So it would also take order of n time for deleting a node at the end of the linked list or at some position P. So this will be order of n, and this also will be order of n. Okay, so this is the requirement. Right, so if a pointer P is given pointing to some node in the singly linked list, let's say this is a P pointer and it contains the particular location, it is pointing to a particular node in linked list. So if this is given, then if we are asked about the insertion of a node, then definitely even if it is at the beginning or end or at particular position, then it is going to take order of n time because it requires the traversal of the entire linked list. Or if it is deletion also, then also we need to traverse and it will require order of n time complexity. Okay, so this was about the time complexity involved. Now what are the drawbacks of the singly linked list? So this is the basic structure of the linked list we have started with. So the drawbacks, if you ask, so what could be the drawbacks? First drawback could be we can traverse only in one direction, right? We cannot go back because every node contains the address of the next corresponding node. Okay, if it is 100, this is 200, this is 300, and this is 400. So every node contains the address of the next corresponding node, right? So we can't traverse backward, right? So one of the drawback could be that we cannot move backward, or we cannot go back. Why? Because each node contains only one pointer to the next node. Okay. Since each node contains only one pointer to the next node, we can't go backward. So this is one of the drawback of a singly linked list. The second drawback is that the very last node of a linked list, in the address field we have this null value. So this is a kind of misuse, that we can't use this address space. If we can use, we can also put some values there in this, although it is not required. This is an indication that the list is ending, but this is just not utilized properly. This address space is not, address pointer is not utilized properly here. Okay, so this could be one of the drawback, like the last node next pointer means where we store the address of the next node. The last node next pointer is always underutilized, not utilized properly, because it is stored with the value null. Okay, so this could be one of other drawback. And the third drawback is, to eliminate the above drawbacks, we need to implement the circular singly linked list. Like, since this last node, it is not a drawback, it is just a certain uh, uh, outcome from the above two statements, that if we have to utilize this last node, okay, so in this we can store the address of the very first node, that is 100. Okay, so in that way it will point to the very first node, right? So this way it becomes a circular linked list. Okay, circular singly linked list. So it is important to write it down, like, to eliminate the above drawbacks, we can implement from singly linked list circular single linked list. Okay, so this could be an implementation for that. So we'll see next about how we can do for circular linked list, how we can insert the nodes for a circular linked list, so that there could be some certain restriction when we insert a new node at the beginning or at the end or somewhere in between. So this could be a thing that we need to discuss, and same goes for the deletion as well. So we'll next see how we can insert a new node at the beginning or at the end of a circular linked list. By the way, if we have a circular linked list, then definitely if we are having a certain position where we need to insert a new node, so for that it becomes a single linked list only. So only the thing will change if we have to insert at the beginning or at the end. Okay, we will see this in the next videos associated with the circular singly linked list. Okay, till that, thanks for watching. Bye bye.